So in this set of slides, we're going to go over one of the most fundamental data structures that we have, sort of one of two data structures that should always be sort of your go-to data structure. And my favorite way to talk about hash tables is to start with going through an implementation that's the default in Python, so the programming language that we mostly use for the algorithms we program in this class. Before that, though, I just want to show you how sort of important data structures are just by showing you how it's implemented in a few common languages. So if you take Python 2 and 3, you've got two built-in hash tables. You've got the hash table itself, and then you've got a set. You take C++, and it's part of the standard library. You have the unordered map and the unordered set. If you look at the map version, so if you get rid of the unordered part, that's going to be a red-black tree. And same thing if you look at just a set, that's going to be a tree implementation. So you've got to use the unordered map and unordered set. I will say, though, if you're going to use a hash table, there is an implementation in C++ called the Swiss table, developed by Google. That's just insane. I'll have some links to it in your homework assignment this week if you just feel like watching a video and sort of being blown away by some of the engineering put into a C++ hash table. In Java, you have the hash map and hash set, both part of the standard library. In Rust, you have the hash map and hash set. In Swift, they call it a dictionary and a set. JavaScript, it's built into the language. So like in Python, if you use brackets, that's sort of a hash map type of thing. And then the set keyword is a set. C#, you have dictionary and hash set. And as you can see, there's a variety of names. You've got map, you've got dictionary. Those are sort of synonymous. And then all these languages also have something that's referred to as a set. You might be wondering sort of what's the difference between a map and a set. Well, a map is just something where you've got a key that maps to a value. So that would be the map, also called the dictionary. And if you have a set, that means you're really just storing the key values and there's no value associated with it. So mild difference between the two, but they do sort of have their own distinct uses. The rule of thumb here is, I should probably just say, you should just use a vec or a hash map. So, this thing is going to be your list in Python, an array in C++, or a vector in C++. That would be a, let's see, and I'm trying to remember my Java. I believe that would be a array list in Java, because it has to be named longer because it's Java. If you're talking about Rust, that's a vec, and then pretty much every language is going to have that built in as well. And you've got the hash map, which we're talking about here. So if you're trying to figure out your data structure, you should almost always just go with one of those and forego the tree. So probably don't use a tree. You've also got heaps. Probably don't want to use heaps. The only time you want to use these other data structures is if you're trying to do something in specific. So when you use a heap, when you're trying to repeatedly get the min value or the max, so extract min or max. And when you want to use a tree, if you're repeatedly doing a lot of insertions and deletions. And when I say repeatedly, I'm just saying sort of you're doing more of those in comparison to the number of operations you're doing that aren't those two things. So if you're doing a lot of random access, or if you're doing a lot of accessing your data in order, you probably just want to use an array or a vector array list, whatever you want to call it. All right, that's where I'll cut this first intro video. In the next video, we're going to go through the Python implementation of a hash value and kind of look beneath the hood a little bit.